Okay, so we're going to talk about synthesis, or sometimes referred to combination reactions. And I think this is a fairly straightforward reaction. Again, the general equation, A plus B gives you AB. I don't really like this particular equation just because we don't really have an elemental symbol A, but it gets to the point. So basically with a combination reaction is you take two or more reactants and you're combining them to give you one product. So usually, but not always, you'll have, for example, elements combining to give you compounds. So that's basically what you're looking for. So the easiest of these combinations is kind of what we see here. So here we have the element sodium. And sodium is a metal, and at room temperature it's found like a solid. So that's its state. And then chlorine is a nonmetal, and it's a diatomic because, again, remember Brinkelhoff, and it's a gas. Well, what do we have? We have an element, a metal, and a nonmetal. Okay? And if you see an arrow, right? Well, that means a reaction is going to happen. So what's going to happen? Well, these two are going to combine. Right? And what do metals and nonmetals combine to make? Ionic compounds. So you'll have to remember, that sodium, because it's in group 1, forms a +1, and chlorine, it's a halogen, and so it's group 7A or 17, and it forms a -1. And if we want to have a neutral compound, it's going to produce sodium chloride, which at room temperature, ionic compounds are referred to as salts. It's a solid. The only thing left is to balance this. So I would first go to metals, 1 sodium, so far balanced. Then I would go to nonmetals, 2 chlorine. There's only 1 here. I'd have to put a 2 here. So there's no hydrogens and oxygens, but step 4 for balancing equations, because I put that coefficient of 2 in front of the sodium chloride product, I need to now put a 2 in front of that sodium metal over here. And I find this really interesting. We have an explosive, really reactive metal like sodium and a noxious, gas like chlorine. And when they combine, they have completely different properties like salt, which we put on our French fries, which is really interesting. But what I really want you to think about is this is the easiest type of combination, is you're going to have a metal, a nonmetal, and what are they going to make? An ionic compound that we call a salt. So let's do a really easy one. Let's say, well, what if I have, magnesium combining with oxygen? What's going to happen? Well, first you got to realize, okay, magnesium is what? Mg, and it's a solid because it's a metal. And at room temperature, metals are solid. Then you got oxygen. It's a diatomic, and it's a gas. And what is it going to produce? Well, we know it's going to combine to produce magnesium oxide. So we have to look at the charges, because when I have metals and nonmetals combining, they form positive and negative charges. So we got to figure out, we got to figure out those charges. So magnesium, group 2, is a 2 plus. Oxygen, group 6A or 16, is a 2 minus. So it's a 1 to 1 ratio. And that's a solid. So with balancing, 1 magnesium, 2 oxygen, if we look at the O2, and there's only 1 in magnesium oxide, so we have to put a 2, go back, change the coefficient in front of the magnesium to make sure it's balanced. Everything looks good, and there you have it. So, why is this a combination reaction? Well, again, we're taking 2 or more reactants and combining them to form one product. What are our 2 reactants? A metal, a nonmetal, forming our ionic compound, or our salt. So, hope you enjoyed the video. Hope it makes sense. Go ahead and leave any comments in the comment section, and thanks for listening.